We'll begin by learning about the difference between absolute and local maximum and minimum values, and then walk through some examples. The maximum and minimum values of a function can be classified as either local or absolute. A local max or min of a function is the highest or lowest point within a small neighborhood. A small neighborhood just means points near the highest or lowest points. Down here on our graph, this point is a local minimum because it is the lowest point in the neighborhood of points around this point. This point here is a local max, and then this point here is also a local max. Now let's talk about absolute max or mins. An absolute max or min is the highest or lowest point across the entire domain. So that just means that the absolute max or min is the highest or lowest point among all the points on the graph. In our graph down here, there is no one point that is smaller than all the other points, but there is a point right here that is the highest point of all the points, and that is an absolute max. We say that a point is a local max at x is equal to c if f of c is greater than or equal to f of x for all x close to c. And then the same thing happens for a min. We have a local min at x is equal to c if f of c this time is less than f of x or equal to f of x for all x close to c. Here's one important note. A local maximum or minimum cannot occur at an endpoint because it requires points on both sides for comparison. A point is an absolute max at x is equal to c if f of c is greater than or equal to f of x. That's the same thing as the local max, but now it has to be for all x in the domain. And then something similar is true for an absolute min at x is equal to c. F of c is less than or equal to f of x for all x in the domain. Unlike local max and mins, an absolute max or min may occur at an endpoint. Let's now walk through an example. We are going to state the local and absolute maximum and minimum values of the function and where they occur. Let's start by looking at the points on our left. So we'll start with x is equal to 0, and then we'll go to the right. When x is equal to 0, our function is this value right here. Since this is an endpoint, this point cannot be a local max or min. It could be an absolute max or min, but if you look at all the other points on the graph, you can see that there are points higher than this point, so it is not an absolute max. So we just say that that point is neither an absolute or a local max or min. Let's now look when x is equal to 1. At x is equal to 1, we have a local min. Our function at x is equal to 1 is less than or equal to the points around it. Let's now look when x is equal to 2. This one's a little bit tricky. In a neighborhood around x is equal to 2, notice that our function value is equal to the points to the right and to the left. That means that at x is equal to 2, we have a local min and a local max. Let's now look at x is equal to 3. This one is just like x is equal to 1, and we are going to have a local min. Now let's look when x is equal to 4. That is going to be a local max, but it's not going to be an absolute max because there are points to the right bigger than that point. So let's just say x is equal to 4. We have a local max. Now let's look when x is equal to 5. That point is neither a local or an absolute max or min, so we won't write anything down for that point. We can say the same thing when x is 6. That is not a max or a min. But if we go a little bit further to where x is 6.5, we have a local min. So let's write down here x is 6.5. We have a local min. When x is 8, we don't have a local or an absolute max or min. But when x is equal to 9, we have a local max, and then that point is the highest point in our graph, so we also have what's called an absolute max. So we'll write down at x is equal to 9, we have a local and absolute max. Hang with me, we have 2 more points to go. When x is 10, we don't have a max or a min. And then now let's look at what happens when x is 11. Because that point is an endpoint, we cannot have a local min, but we can have an absolute min. And if you look at all the values of our function, when x is 11, that is the smallest value. So we're going to say that at x is equal to 11, we have an absolute min.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.